All right, last lesson of this unit, graphing, everyone's favorite. So this is actually what a rational graph looks like. As you notice, there are multiple curves. You have a bunch of asymptotes. Remember those from when we talked about logs and exponentials. So over on the right, you will see, sorry, that's the left. Right and left are hard. Over on the left, you'll see the three different things you need to find to be able to graph. The first thing you're always going to look for is your vertical asymptotes. The reason that I made this first is because your vertical asymptote suggests your domain. So this whole time we've been saying, okay, x cannot be 2. Well, if you look here, you have a vertical asymptote as x equals 2. And if you notice, neither of your two purple graphs or blue graphs, whatever color that is, neither of them touch at x equals 2. So that's what we've been finding this whole time when we look at the domain. So you get that from setting your denominators equal to 0. X-intercepts are very similar to domain, except you're going to set your numerators equal to 0. Factor them, set them equal to 0, solve for x. So here they had an x-intercept at the point 1, 0. And lastly, you need your horizontal asymptote, or your HA. This is found just by looking at the degree of your numerator and your denominator. So remember, like x squared plus x, that degree would be 2. 3x to the third plus 4x squared, your degree would be 3. It's your highest exponent. So if your degrees are equal, then your horizontal asymptote is the two coefficients divided. So for instance, if I had 3x squared minus 4 all over 6x squared plus 1, because my two degrees are the same, I'm just going to take 3 divided by 6. So that means my horizontal asymptote is the line y equals 1/2. So if your degrees are equal, that's how you find your horizontal asymptote. If the degree is on top is greater, then there isn't a horizontal asymptote. If the degree on bottom is bigger, then the horizontal asymptote is y equals 0. So you can see here the horizontal asymptote is a line y equals 1, which tells me that for this graph, the degrees were equal, and they had to divide their leading coefficients. So what I'm going to have you do right now for the examples is we're not going to graph anything. We'll save the actual graphing piece for class. We're just going to go through and label our vertical asymptote, the x-intercepts, and our horizontal asymptote. So for the vertical asymptotes, remember that's just your domain. So I'm going to abbreviate that VA and write in here domain. So again, for my domain, I look at my denominator. So if I set my denominator equal to 0, it's already factored. I don't have to factor it. My vertical asymptote is going to be the line x equals 0. So then we have to look at our x-intercepts. We get the x-intercepts from our numerator. So I'm actually going to factor this. So I need to find two numbers that multiply to -4 but add to -3, and that's -4 and 1. So if I factor this, I have x minus 4 and x plus 1. So then you guys all know from the domain, because we've been doing this forever, I just look, what number would I put in for this x to make it 0? And I know that would be 4. The number to put in this x to make it 0 would be -1. So my x-intercepts are the points 4, 0, and -1, 0. One thing I want you to remember is that your asymptotes are lines, but your x-intercepts are points, so you need to write them that way. This should be the equation x equals a number, and these should be your 2 points. All right, the last thing we need to come up with is our horizontal asymptotes. So again, this is where we compare our degrees. The degree of the numerator, so I'm going to say dn is 2. The degree of the denominator is 1. When the degree of the top is bigger, there is no horizontal asymptote. So that's what you need to look at every single time. Factor domain, set equal to 0. Factor numerator, set it equal to 0. And then compare your degrees to decide whether there's no horizontal asymptote, an asymptote at 0, or your coefficients divided. I know I said factor domain and set it equal to 0. I totally meant denominator. All right, our second example, 4x minus 12 all over x minus 1. So again, I'm always going to start with my vertical asymptote, aka your domain. My denominator is x minus 1. It doesn't need to be factored at all. That's all you can do. So I just need to think, what x value do I put in its place to get me 0? And that is a positive 1. So my vertical asymptote is going to be at 1. My x-intercept. Again, I get that once everything is factored. So I look at the top, and again, the top is something that can factor. 4x minus 12 has a GCF of 4, so that comes out to be x minus 3. So from here I look, x minus 3. If I set that equal to 0 and solve, that gives me an x equals positive 3. So my x-intercept is the point 3, 0. This one only has one x-intercept. And lastly, my horizontal asymptote. So we're going to compare the degrees. The degree of the numerator is 1. The degree of the denominator is 1. Since they are the same, I'm going to divide my two coefficients. The coefficient at the top is 4 and the coefficient at the bottom is 1. So my horizontal asymptote is the line y equals 4. So for class, we need to be able to graph the line x equals 1, the x-intercept 3, 0, and the horizontal asymptote y equals 4. So try on your own. I want you to do the exact same things. I want you to label the domain, find the x-intercepts, and decide what type of horizontal asymptote you have. Once you guys are all in class, we will graph these together and work on the homework. Good luck.